Now, next chapter which we are going to discuss here is that is your trigonometric functions. And the first topic of trigonometric functions is based on trigonometric identities. Now, before discussing trigonometric identities, I would like to discuss what is the meaning of identity. What do you mean by identity? Identity is the relation which is true for all the variable oblique variables. Now, what is the example of this? For example, we have a plus b whole square is equal to a square plus 2ab plus b square. So whatever is the value of a and b, the relation is always going to be true. For example, a plus b whole cube, this is equal to a cube plus 3a square b plus 3ab square plus b cube. So once again, whatever is the value of a and b, you substitute it on the right hand side as well as the left hand side. The relation is always going to true hold for all the values. Now, this is the meaning of identity. Identity means the relation which is true for all the values of variable oblique variables. So what do you mean by trigonometric identities? Trigonometric identities are for example, sin square theta plus cos square theta equals to 1. You can take any value of theta, the relation is always going to be true. Now, secant square theta minus tan square theta, this is 1. Then you have cosecant square theta minus cot square theta, that is 1. Then you have sin theta, which is 1 over cosecant theta, cos theta, which is your 1 over secant theta, and tan theta, which is your 1 over cot theta. So these are your basic trigonometric identities. So today's topic is exactly based on the trigonometric identities. Now, so the first question which we are going to discuss here is, we have to prove that secant raised to power 4x minus secant square x is equal to tan 4x plus tan square x. So we have to prove that secant 4x minus secant square x is tan 4x plus tan square x. Since in this question terms are in terms of secant and tan, so we can proceed from any side, that is your left hand side or the right hand side. So let us start with left hand side. It is secant 4x minus secant square x. So if I take secant square x common, you can see that it comes out to be secant square x minus 1. Now, at each and every step you must write down the reason why we are replacing particular term, because secant square x minus tan square x is 1. So therefore secant square x minus 1 is equal to tan square x. So that means from first and second I can replace secant square x minus 1 with tan square x. That is, it comes out to be secant square x into tan square x. Now, since on the left hand side both the terms are in terms of tan, now again from 2, secant square x is 1 plus tan square x, into tan square x. So which comes out to be, that is your tan square x plus tan 4x, which is your right hand side here. So depending upon from question to question, so using the appropriate trigonometric identities comfortably, very easily, you can reach from left side to right or right side to left here. Only thing is that you require a lot of practice to solve questions relating to, that is your trigonometric identities. Now the next question is, for example, we have to prove that sin raised per 6x plus cos raised per 6x is 1 minus 3 sin square x into cos square x. Now, this is what we have to prove here. Now, you can see that in this question, the identity which we can use here is, because sin square x plus cos square x is equal to 1. Since we have to reach till sin raised per 6x, so therefore, cubing both sides. So what do we have? Sin square x plus cos square x whole cube, which is equal to 1. So it is a cube plus b cube plus 3ab into a plus b is equal to 1. That is simply using the formula, that is your a plus b whole cube is a cube plus b cube plus 3ab into a plus b. So this implies sin 6x plus cos 6x plus 3 sin square x into cos square x. This is equal to 1 because sin square x plus cos square x is 1. So this implies, you can see from here, sin 6x plus cos 6x, this is equal to 1 minus 3 sin square x into cos square x. So this was the result which we were supposed to prove here. Similarly, exactly the question which is based on this is, you may be asked to prove that sin 4x plus cos 4x as 1 minus 2 sin square x into cos square x. In the similar manner, we will start the question, because sin square x plus cos square x is equal to 1. So squaring both sides, squaring both the sides, so we have sin square x plus cos square x whole square, this is equal to 1. So it is a square plus b square plus 2 times ab is equal to 1. So you can see here, so from the above equation, we have sin 4x plus cos 4x as 1 minus 2 times sin square x into cos square x here. They are very easy to prove, they are very interesting questions. Only thing is, again and again, you should try to solve these questions, you should keep on doing these questions, because trigonometry means that you require a lot of practice. There are certain topics in which you require proper application of the formulas, but in trigonometry, of course, you need to apply the formulas properly, but you require a lot of practice. Now, next question is, so it is tan x over 1 minus cot x. What we have to prove here is tan x over 1 minus cot x plus cot x over 1 minus tan x, and this should be equivalent to secant x into secant x plus 1. So what we have to prove here is tan x over 1 minus cot x plus cot x over 1 minus tan x is equal to secant x into cosecant x plus 1. So what is the left hand side? It is tan x upon 1 minus cot x plus cot x upon 1 minus tan x. So we will convert all these terms in terms of sine and cos. Now, because tan x is sine x upon cos x upon 1 minus cos x upon sine x plus cot x is cos x upon sine x upon 1 minus tan x is sine x upon cos x. So this can be written as, if you simplify this comes out to be sine x upon cos x upon sine x minus cos x upon sine x plus, what is that? It is cos x upon sine x upon cos x minus sine x upon cos x. Again you simplify this, it comes out to be sin square x upon cos x into sin x minus cos x plus, this is cos square x upon sin x into cos x minus sin x. Now again if you simplify this, that is, before simplifying you take the LCM. LCM is what? This is cos x into sin x minus cos x. So this is the LCM here. So when you simplify this, it will come out to be sin cube x, because here it is cos x minus sin x, but in the LCM term is sin x minus cos x. Here you have positive sign. This one is negative of it. It is minus cos cube x here. Now it is of the form a cube minus b cube, because a cube minus b cube is equal to a minus b into a square plus ab plus b square. So of course we are going to use this formula here. So this is equal to, this is sin x minus cos x into, this is sin square x plus cos square x plus sin x into cos x upon, this is sin x into cos x into sin x minus cos x. So this term will cancel. So what is the value of sin square x plus cos square x? 1 plus sin x into cos x upon sin x into cos x. Now separate these two terms. So this can be written as 1 upon sin x into cos x plus sin x into cos x upon, this is your sin x into cos x. So what is 1 over sin x into cos x? It is cosecant x into secant x plus 1, which is your right hand side here. So this way you can see that we have been able to reach to the right hand side from the left hand side just by converting the terms of tan and cot in terms of sine and cos here. You require a lot of practice. Again and again I am going to repeat these words. You require a lot of practice plus proper application of algebraic identities, and you have the required result. Now next question is tan cube x upon 1 plus tan square x plus cot cube x upon 1 plus cot square x, and what we have to prove here is 1 minus 2 times sin square x into cos square x upon sin x into cos x. So this is what we have to prove here. Now again, left hand side, this is tan cube x upon 1 plus tan square x plus cot cube x upon 1 plus cot square x. Now, because secant square x minus tan square x is equal to 1, so this implies secant square x is equal to 1 plus tan square x. Because cosecant square x minus cot square x is equal to 1, so this implies cosecant square x is equal to 1 plus cot square x. So these two identities we are going to use in this question in the first step, very first step. So from here, so using 1, the above can be written as, this is tan cube x upon secant square x plus cot cube x upon cosecant square x. So as we did in the previous question, you simply change all the terms of containing tan, cot, secant, cosecant in terms of sine and cos. Tan cube x, this is sine cube x upon cos cube x upon 1 over cos square x plus cos cube x upon sine square x upon 1 upon sine square x. So if you simplify this, you can see from here it will come out to be sine cube x upon cos cube x into, this is cos square x plus cos cube x upon sine cube x into sine square x. Whenever there is a common factor, so we can cancel the common factor. You can see from here cos square x will cancel with cos square x, sine square x will cancel with sine square x. So what is the remainder here? Sine cube x upon cos x plus cos cube x upon sine x here. Again take the LCM. LCM is what? It is sine x into cos x. It comes out to be sine 4x plus cos 4x. So that's it. Now, because sine square x plus cos square x is equal to 1, so therefore sine square x plus cos square x whole square, it will also come out to be equal to 1. So actually squaring this, sine 4x plus cos 4x plus 2 times sine square x into cos square x, this is equal to 1. So that means the value of sine 4x plus cos 4x, it comes out to be 1 minus 2 times sine square x into cos square x. So which means from 2 and 3, that is using 2 and 3, the above can be written as 1 minus 2 sine square x into cos square x upon sine x into cos x. So what was the right hand side? That is same as 1 minus 2 sine square x into cos square x upon sine x into cos x. So which is your right hand side here? So this proves the that is your required result, or this shows that left hand side is equal to the right hand side here. Now the next question which we are going to prove here is that 2 sin x cos x minus cos x upon 1 minus sin x plus sin square x minus cos square x is equal to, that is your cot x. So this is the result which we are going to prove here? This is the question, that is your 2 sin x cos x minus cos x over 1 minus sin x plus sin square x minus cos square x is equal to cot x. Generally, in all these questions, what we have to see here is that can we take anything common from the numerator or the denominator? And can we straightway use the trigonometric identities? Like in this case, now first of all, write down the left hand side. This is 2 sin x into cos x minus cos x upon 1 minus sin x plus sin square x minus cos square x. So we can take cos x common from the numerator. It comes out to be 2 sin x minus 1. Now in the denominator, combining 1 minus cos square x plus sin square x minus sin x. So purposely I have combined these two terms. Why? Because sin square x plus cos square x is 1. So therefore 1 minus cos square x is equal to sin square x. So the above result can be written as cos x into 2 sin x minus 1 upon, this is your sin square x plus sin square x minus sin x. So this can be written as cos x into 2 sin x minus 1 upon 2 sin square x minus sin x. Again, can we take anything common from the denominator? Yes. So it is cos x into 2 sin x minus 1. Sin x is common. 2 sin x minus 1. This factor will cancel. It comes out to be cot x, which is your right hand side here. So questions are easy, very easy to solve, but again requires a lot of practice. Now next question is, what we have to prove here is sin 8x minus cos 8x is equal to sin square x minus cos square x into 1 minus 2 times sin square x into cos square x. Once again, to start with your left hand side, which is your sin 8x minus cos 8x. Can we factorize this? Yes. How? Because a square minus b square is a plus b into a minus b. So that means the above relation can be split up as sin 4x plus cos 4x into sin 4x minus cos 4x. But the second term can be again factorized. How? So this is sin 4x plus cos 4x into sin square x minus cos square x into sin square x plus cos square x. So use your identity that because sin square x plus cos square x is 1, so this is equal to sin 4x plus cos 4x into sin square x minus cos square x. Now, can this be written as sin square x plus cos square x whole square minus 2 times sin square x into cos square x into sin square x minus cos square x? So how we are using this? Because a square plus b square can always be written as a plus b whole square minus 2ab. So this is equal to 1 minus 2 sin square x into cos square x into sin square x minus cos square x. So what is the right hand side? It is sin square x minus cos square x into 1 minus 2 sin square x into cos square x. So that is your right hand side here. Is that clear? So this way you can prove the questions relating to trigonometric identities. Now next question is cot 4x plus cot square x is equal to cosecant 4x minus cosecant square x. Next question which we are going to solve here is we have to prove that cot 4x plus cot square x is equal to cosecant 4x minus cosecant square x. Again, you can start from left hand side as well as the right hand side, or from the right hand side. What is the left hand side? It is cot 4x plus cot square x. So as we discussed in the previous question, so can we take anything common from these two terms? Of course we can take common. Let's take cot square x common. It comes out to be cot square x plus 1. Now because cosecant square x minus cot square x is 1, so that is cosecant square x is equal to 1 plus cot square x. So use this here in the above step. So cot square x into cosecant square x. Since the right hand side contains two terms, both are in terms of cosecant, so therefore this cot x or cot square x needs to be changed in terms of cosecant. So from 1 we have cot square x is equal to cosecant square x minus 1. So use this result in the above step. It comes out to be cosecant square x minus 1 into cosecant square x. So what is that? It is cosecant 4x minus cosecant square x, which is your right hand side here. So this way you prove the result here. Now the next one is we have to prove that 2 times secant square x minus secant 4x minus 2 times cosecant square x plus cosecant 4x is equal to 1 minus tan raised to power 8x upon tan 4x. So in this we will be using 3 trigonometric identities, or 3 trigonometric ratios we are using. They are secant, cosecant and tan. Now what is your left hand side? It is 2 secant square x minus secant 4x minus 2 times cosecant square x plus cosecant 4x. So from the first 2 terms we will take secant square x common. It comes out to be 2 minus secant square x minus, you take cosecant square x. Be careful, students generally do mistake in taking, whenever the negative sign is there, they mistake in taking cosecant square x or any term common when 2 terms are in terms of negative and positive. So it is 2 minus cosecant square x. Now because secant square x is 1 plus tan square x and cosecant square x is 1 plus cot square x, so obviously we will be using these two results in the above step. So secant square x can be written as 1 plus tan square x into 2 minus, you put the bracket here. Now cosecant square x, it is 1 plus cot square x into 2 minus 1 plus cot square x. Now this is your 1 plus tan square x into 1 minus tan square x minus 1 plus cot square x into 1 minus cot square x. So what is that? It is 1 minus tan 4x, because a plus b into a minus b is a square minus b square, minus 1 minus cot 4x. Since the right hand side is in terms of tan, that means you need to change cot to tan. Now, can I write this as 1 minus tan 4x minus 1 plus cot 4x. So if you open the brackets here, you can see that 1 will cancel and we will have cot 4x minus tan 4x. Since the final result or the right hand side is in terms of tan, we will change cot to tan. How? It is 1 over tan 4x minus tan 4x. Now if you take the LCM, it comes out to be 1 minus tan 8x upon tan 4x. That is your right hand side here. That is 1 minus tan 8x upon tan 4x here. Now next question is, we have to prove that cos x into tan x plus 2 into 2 tan x plus 1 is equal to 2 times secant x plus 5 times sin x. That is what we have to prove here, is that it is 2 times secant x plus 5 times sin x. So again, starting from the left hand side, this is your cos x into tan x plus 2 into 2 tan x plus 1. So this can be written as cos x into 2 times tan square x plus 4 tan x plus tan x plus 2 here. Now this is cos x into 2 plus 2 tan square x plus 5 tan x. Now this can be written as cos x into, take 2 common, it is 1 plus tan square x plus 5 tan x. Now because secant square x is equal to 1 plus tan square x, as we have already discussed this identity, use this in the above step. So it is cos x into 2 times secant square x plus 5 times tan x. Now open the bracket. 2 times cos x into secant square x plus 5 times cos x into tan x. So one of the factor will cancel from here because they are reciprocal of each other. So what is that? So we have 2 times secant x plus 5 times sin x, which is your right hand side here. That is 2 secant x plus 5 sin x here. Now next is, we have to prove that secant square x plus cosecant square x is greater than or equal to 4. Now can we write down secant square x as 1 plus tan square x? This is your left hand side. Now left hand side is secant square x is 1 plus tan square x and cosecant square x is 1 plus cot square x. So this is equal to 2 plus tan square x plus cot square x. Now can this be written as 2 plus tan x minus cot x whole square plus 2 times tan x into cot x, because a square plus b square can be written as a minus b whole square plus 2 times of ab. So can this be written as 2 plus 2 times tan x cot x as 1 over tan x plus tan x minus cot x whole square. So what is that? It is 4 plus tan x minus cot x whole square, because this quantity is always going to be greater than or equal to 0, so that is why this is greater than or equal to 4 here. So this way you can see that we can solve the questions relating to trigonometric identities. All these questions or the questions based on trigonometric identities are very easy to prove, very interesting and very challenging also. Only thing is you require practice and more of practice. Thanks a lot.